Hi, recently Marcus and I did a talk at the MLCon Berlin, and because it was very well received, I wanted to share it, at least parts of it, with a broader audience. So I'm talking about the rise of local AI today. As we all know, data is being created and used everywhere. That's locally, on the edge, on device, and we'll be using those three terms interchangeably. Now, because data is used and created everywhere, it's decentralized. Our world is inherently decentralized. So we need a decentralized computing paradigm. And this is basically the reason for a huge mega shift occurring in computing from a centralized cloud-based model towards a decentralized model, which we now call edge computing. And this is nothing new. We've seen the shift back from centralized to decentralized and back again before, from the mainframe to client server architecture, and now again to edge computing. So edge computing is a growing and rapidly growing field and technology. And at the same time, we all know AI is here, is everywhere and growing very quickly. So both markets are supposed to be very big and growing fast. Now, once we combine those two mega trends, what we get is edge AI, and that's what I'm talking about today. Edge AI as opposed to cloud AI means the AI model is running not on the cloud, but directly on the edge devices, like on mobile phones, the car, or your personal computer. This has many benefits. First of all, it's offline capable. You don't need a constant internet connection. So that's great whenever you have some, mobility going on or remote areas, or just a reason not to have an internet connection. This also means your data is more secure if you keep it on your premise, on your device. And of course, it stays private. There's no need to share your data with the AI provider. This also means you have no issues with the bandwidth bottleneck. And of course, your AI application can be very fast. It can be way faster than if you need to go to a distant cloud. You can guarantee response rates, and even near real-time or real-time is possible. This will also lower your cloud and networking costs, and last not least, it's more sustainable. With regards to sustainability, you can think of this as shopping locally. When you keep your data locally and use it locally, it's basically like, for example, buying apples from your local farmer instead of keeping your data on distant cloud servers and then working, getting it back to your device when you need it, which is more like buying apples that come from New Zealand in the next German supermarket. And every mega shift in computing so far has been empowered by core enabling technologies. And it's the same with edge AI. And specifically for edge AI, there are two main technologies, namely small AI models, on-device AI models, and on-device vector databases. And again, on-device can be exchanged for local or edge. And with regards to AI models, in this case, we mainly mean foundation models, which are the general models, often also called LLMs, large language models, and the newer term SLMs is for small language models, which means it's not a greatly defined term, but it means it's significantly smaller than a typical large language model. And for on-device vector databases, we sometimes see the term vector database hidden behind a term like semantic index or vector search. Okay, so first let's have a quick look into a practical example before we go on to look at on-device AI models and then on-device vector databases. Probably you've all seen the Apple keynote last year, and the big new thing was local AI on the phone, and it works with a on-device vector database and an on-device AI model. So both is located on the phone, and this is used when a question is, let's say, not too complex, easy enough that the local AI can respond to it. And then, of course, it works offline whenever you need it. it keeps your data private, and it's super fast. Once you have a question that's more complex or maybe needs a lot of external knowledge, the request will go to the cloud and the cloud AI will provide an answer back to you. And this is the setups we expect to be seeing more. So instead of only cloud AI, which is predominant model at this moment, which makes a ton of sense because it's the easiest to start from, or like full edge, we'll see all kinds of hybrid models. And this depends on your setup, how much cloud and networking costs can you bear? What about your energy consumption? Does it need to be offline capable? Do you have any quality of service parameters or speed requirements? Last not least, do you want or need to keep your data private? If you think about data privacy, I think especially with regards to AI, this is important. For example, imagine an on-device AI assistant that really, can help you stay on top of things and is doing really great work for you by using your emails, your WhatsApp chats, your any other messages, calendar entries, etc. And this is awesome. This is great. But would you be willing to share all this data to a cloud AI in order to get that kind of help? I'm not sure. So I think this is a concern for many people, which makes edge AI even more important. Now, let's look into small language models. First of all, we are, of course, starting with language models in general, and we've seen a lot of foundation models coming up in the last years, exponential growth, and alongside, they have become bigger and bigger, and yeah, AI training costs have skyrocketed, as well as power consumption, and bigger was always better until at one point exponential growth stopped and we saw more smaller models being released. And amazingly enough, those smaller models had good quality, sometimes even outperforming bigger ones. However, we are not talking about SLMs yet because those are models that are still rather big. Now, early last year, we saw the first real small language model appearing, which was the Gamma 2B from Google, and this is significantly smaller. And since then, we've seen a ton of small language models appearing, and I didn't update the slide for the talk today, and it's already 3 months old. So in between, already at least 5 significant and high quality small language models have appeared in that time frame. So small language models are very much cheaper, often 100 times cheaper. So depending on your use case, it might make sense to consider that. And at the same time, they're also a lot faster, sometimes up to 10x. Now, if you look a little bit into detail, we're going from GPT-4 to GPT Mini. We see a 100x time reduction in price, while at the same time, the quality stays nearly the same. This is not too bad, right? And we see similar comparisons across all kinds of models. So small language models are becoming a reality. To quickly summarize this, advantages of small language models: they are efficient and faster. They are less power hungry and don't have any restrictions the cloud offers. They are cheaper, more sustainable. If you have something where you want a domain-specific task, they are very efficient when it comes to fine-tuning and specializing. And of course, they can run on many devices, like, for example, mobile phones or commodity hardware, maybe your local laptop, and this heightens privacy and security. Okay, now that we've talked about the small language models, the on-device language models, basically, let's have a look at on-device vector database. And for this, we are going to start, first of all, with vector databases in general. And vector databases basically are the databases for AI. So because of this, we saw, of course, investment soaring for vector databases. And what happened, all traditional database players also ran in and extended their technologies to also support vectors and vector search. So the number of companies using or wanting to use vector database is rapidly growing. We saw that OpenAI acquired a company specifically for their vector database capabilities because, of course, in the background, they're also using vector databases, and traditional database players are extending. Soon up to 75% of those players will have extended their technology to support vectors. We also saw that reflected, and this is a very specific platform for people interested really in databases. And there we saw that vector databases gained a lot of popularity at that time. And also in a survey from, I think, Databricks, we saw that vector databases gained more uptake, has grown more than other large language model Python libraries, which is pretty impressive. So yeah, what are vector databases? First of all, AI models use vector embeddings, and vector databases store vector embeddings, which means one of the key components with which AI models work can be stored and queried and searched easily within a vector database. And this is, of course, where value comes from. Then, of course, you have search and querying capabilities, and often you have additional context and filtering mechanisms. Now, let me explain that in this slide a little bit in more detail. So you have all kinds of data, PDFs, text files, images, videos, audio, whatnot, multimodal data. And then, in order to make it usable for AI and to store them in a vector database, you need to convert them into vector embeddings. So basically, this whole document becomes a vector. This is done by an AI model. So first of all, you convert your data into vector embeddings. Then you store them into the database, vector database. Now, typically, you would want to store those documents and maybe some metadata alongside the vector embeddings and have a relation. Because then later, when the AI gives an answer back, you can retrieve the source. You can understand where that answer is coming from, to which documents or input it refers. That makes a ton of sense and, makes it also more reliable. And in the background, there's some indexing, where the most popular and important index, I think, is approximate nearest neighbor search. And all this does, it basically empowers efficient similarity search across vector embeddings. So, a little bit deeper look into this. If you as a user have a query, you enter a question alongside some document, it will go to an AI model, and this AI model again will first of all generate a vector embedding. Yeah, we call it query embedding in this case to make it clear. Then, if you use a vector database with this embedding, in the vector database, you can look up nearest neighbors. Now, with the selected nearest neighbors, some filtering can happen, probably also using the query metadata, and then you have some finally retrieved vectors, which go back to the AI model, which finally generates the response using the context provided, and then you get a response. Typically, you would want to generate a response embedding from that and also store it again into the vector database so you can be quicker, more efficient next time. This is basically how a vector database works. And let's have a quick, very, very quick look how that differs from traditional vector databases. Now, from traditional databases, of course. Now, I think I already pointed out, traditional databases add vector search, and the other vector databases are therefore now called pure players. And what we see happening there is they tend to extend their capabilities with more traditional database capabilities. So, they are converging basically, And I think in the future, every database will support vectors. Now, the advantage of traditional databases is that they are robust and mature databases that have been around for a long time, and the database is at the core of all your data, of your application, maybe even your company, right? It's pretty important. So you might want to take that into consideration. Then, of course, a traditional database has many more features that typical pure vector database players do not offer yet, that you probably want to combine with your AI and vector search capabilities. If you have a vector database, you will additionally always also have a traditional database. So that means you will have more databases to maintain, so more maintenance effort. And those are the reasons basically why a traditional database with vector search makes a ton of sense. But of course, pure vector database players are highly specialized. So depending on your use case, you might need features that only pure vector database players offer at this moment, or you might find that in your use case, the vector search is more efficient or provides better filtering that you really truly need. However, as I said, both have its uses over time. They will converge. So, use cases. When do we use vector databases? Vector databases are used in the background to speed up LLM responses. Adding long-term memory, this is to basically, if you have a conversation with an AI, you want to be able to pick it up later, but you also might want it to be able to refer to that and use it for the next query you send, etc. So it gives it long-term memory. It enables multimodal search where you can just, analyze vector embeddings that come from different multimodal data sources. And you want to be able to enhance large language model responses. This is actually, I think, one of the most typical and most important use cases of a vector database, because what it means you can adapt an AI model to your knowledge domain, to your specific need. Now, an AI model, unless, of course, you have specifically trained your own, is a general model. It's trained on public data sets. Now, as a private person or as a company, you have data that is not publicly shared, that you don't want to share publicly, that basically can be data about your users, your policies, your products, anything, right? So in order for an AI to answer questions around that for customers, like a typical chatbot, but also internally to just make the most use of your knowledge base, you need to somehow feed the AI that data. Now, typically what you would do is you would translate all of those PDFs, images, videos, Confluence, texts, whatever, into vector embeddings, store it in a vector database, and then you can use a generic AI model to answer questions about your company's policies, your company's procedures, your company's products, whatever it is. So this is really highly efficient, quick, and super good way to adapt AI models to your knowledge domain. And this is called RAG, Retrieval Augmented Generation, and it's one of the most important vector database use cases and makes basically also AI very affordable for a broad variety of users. Then, of course, the vector database provides you with the similarity search, which is way better than keyword search because it really looks for understanding and meaning instead of pure keywords. And it's also used for caching. That basically is very useful if you use an LLM, for example, in the cloud, and that creates, of course, costs. Caching can reduce your LLM costs and therefore bring calls and therefore bring costs down. Okay, so basically what we've discussed so far was mainly general vector databases. All of this is, of course, true for on-device vector databases, but to really pinpoint where those on-device vector databases we need for Edge AI sit, We first have, of course, the field of artificial intelligence and edge computing coming together, where we have edge, AI, and then the databases come in. And databases that can sit on restricted devices, on small devices that are not cloud databases that can run on the edge, can be referred to as edge databases. And databases that are the databases for AI are vector databases. And at the intersection of all three, there sits edge vector databases, or on-device vector databases, or local vector databases, however you want to call them. Now, a quick look into on-device options, because so far we talked about vector databases in general. Now, our topic is edge AI and on-device uses. Basically, there is something that are pure vector indexes, like FICE is very well known. It's not a vector database. It comes with, some advantages, but also many disadvantages. That's one option. It's not a vector database. You can, of course, build something yourself, but a database really is no make or buy decision. And on device, there's at this moment ObjectBox that's already in the market for quite, nearly 3/4 of a year now. And that's recommended for productive use. And this would be, at this moment, the go-to option. A very quick look, because this, I think, might be too technical for many people, on the comparison from vector search libraries and on-device vector databases. So in a nutshell, vector search libraries aren't persistent. They don't offer continual persistency. So every time you start over, you need to load everything again. If you have a snapshot at all, it's purely working on RAM, which means it's limited by the RAM availability, and it has high RAM requirements, of course. And then it's highly specific. It's pure vector search and nothing more, as opposed to a vector database that offers many more features. And it's really only about vectors, so no other data types. On-device vector database uses I have already explained. So for fast demos and prototypes, and for some use cases, vector search lib is great. Depending on what you want to do, you really need an on-device vector database, especially if you are going for retrieval augmented generation applications. We believe AI any time and anywhere will soon be a reality, because we are seeing the same shift happening as from mainframe to PCs, basically. With AI, it's nearly everywhere already. Small language models are coming out nearly on a daily basis. We have vector databases that are ready for on-device use, and hardware is getting more and more capable. So local AI will soon be a reality and then become a commodity. However, of course, we don't believe it's edge versus cloud. It's always edge and cloud. It's basically adding an edge to the cloud. And so we always have decentralized data and centralized data. And this needs to somehow both be managed. And for this, you need something that's synchronizing this data. And we believe that, especially for AI and for updating decentralized AI applications and models and learning, sending learnings back to a centralized model and updating, from different sources of knowledge, you need something that's a synchronized AI, for lack of a better term. That's it. Thank you. Questions are, of course, very welcome.